This is a demonstration of ASCOT, the Astronomical Collaborative Toolkit, and this demonstration is intended to show um, the recent development in the direction of visualizing larger data sets. We have not shown this feature so far, but this demonstration is well served by using the Create Dashboard function, which allows you to add a custom set of gadgets to a dashboard. For this particular demonstration, we'll use a histogram, scalable scatter, data inquire, a viewport, sky viewer for the imagery, and a name resolver as well. We'll use the name resolver as before to go to a familiar place. This time though we'll zoom out a little bit so that we can get our hands on a little more data and start exploring that region where it's a little harder to look at the data and just be able to tell what's going on. I'm going to remove the restriction that we only return 500 objects in this template. Once again, I'm going to also select another table rather than just using the table suggested by that utility button. I'm also going to put some limits on a few of the magnitudes. I really only want bright objects, and I want model mags GR and I to all have measurements. So this now will take us from dealing with a few hundred objects to more like 1,000 or more. And we start to get to the point where there's a lot going on this plot, at least at the zoom level. It starts to become hard to disambiguate things. Our eye is drawn naturally to this linear feature, but the question is whether we can kind of use the tools at our disposal to discover that feature as well. To do that, we can imagine trying to use color selection. I'm just going to use the R-I color and plotting 100 bins rather than selecting all zoom first. And this main stellar locus looks perfectly reasonable, but there's this obvious chunk of outliers out here, and maybe this may be what that linear feature is, but let's dive deeper. We can also take a look at this in the density plot. Here's the stellar locus over here, and we can even zoom in on that to show that it is in fact shaped the way you expect the stellar locus to be shaped in these colors. But then there's also an obvious overdensity up here in the same sort of region where it is on the histogram over here. So the question now is, can we actually use these tools to gain a little more information? We can select using these histograms and tools. So basically, this allows a user to select the points that fall into histogram bins and then color those points appropriately on both the 2D histogram density plot over here and on the imagery at the bottom. In the future, in this particular implementation, all of the histogramming and 2D density estimation is done in the browser. It may turn out that this is something better served to be done on server, but it is definitely one of those areas of research that is interesting for the future. As expected, all of the objects that are in this color range show up in this color range, and then obviously have this spread. More interestingly, maybe, they also appear to be almost exclusively contained on this linear feature, which, if we zoom in a little bit, we see is actually a satellite trail. So what's happening here is that these objects are being detected in only a single band because the satellite only passed over while that band was being integrated, leaving crazy colors. In particular, I is the only band that actually has a color that really means anything. Yeah.